Hi guys, today we are going to learn about coterminal angles and reference angles. I did make a video twice of going over your homework, but then both of them didn't save, and so I think I'm just going to go over it with you if you send an email individually. Like I'll try to explain it as much as possible. Because the homework itself is actually an easy assignment. I think it's how it was presented was a little bit confusing. So I think once I clarify certain things that you'll find it easy as well. So if you had a hard time with the homework, please email me so I can help you. So today we are going to learn about coterminal angle. So because we are in the algebra world, our angles always start in the coordinate plane. And angle has something called a initial side. So this axis right here, the positive x-axis, is always the initial side of the angle. And so, and then there will be a point where the angle ends, right? So it's the distance between these two sides would be the angle. And wherever the angle ends is called terminal side, just like it ends, right? So coterminal angle, so the prefix co is like a existing or together, right? So it's basically another angle that shares the same terminal side as what coterminal angle is. For example, your angle could be just 20 degrees. But because in our geometry world, angle is only 360 degrees, right? And there is no more angle greater than that. But in the algebra world, you can actually do something like this. So let's say I went around a complete circle, like this. And then I went 20 more. Then what happens is that I share the same terminal side, but now my angle is 360 degrees greater than this 20 degrees. So this angle is 380 degrees. And 380 degree is a coterminal angle of 20 degrees. Does that make sense? So basically, one way to find a coterminal angle is that you add 360 degrees, or if it was written in radians, you will add 2 pi. You might remember seeing a negative angle from your homework problem, and I will tell you how the negative angle is measured. Initial side is still here, and in mathematics, negative always means opposite. So do you remember how our angle went this way? Well, negative angle actually goes to the other direction, like this. So this angle right here has a coterminal side, but because my arrows goes clockwise, this is a negative angle. And I will say this is a negative like 135 degrees. Okay? Negative angles means that it went clockwise instead of counterclockwise. Okay, that's all that is. But negative angle also has a coterminal angle that is a positive. Think about it, guys. If my angle actually started from here and ended here, it would still share the same terminal side. It's just that my angle will be positive. And do you remember how I said you just add 360 to get another coterminal angle? Well, look at this. I'm making a complete circle with this unknown angle x that is a coterminal angle to negative 135 degrees. When you add the absolute value of negative 135 degrees to x degree, you have to get 360. So let me write that. So basically, if you do 360 minus 135, you will get the coterminal angle of 135 degrees, which is 225 degrees. So 225 degrees is a coterminal angle of negative 135 degrees, meaning that you can always find a negative coterminal angle and positive coterminal angles. And actually, there are infinite number of coterminal angles for each angle you choose. Let me show you how that is. So let's say that my original angle was 20 degrees like last time. One way to find a coterminal angle is go one way around, and that will be 360 plus 20, right? Another way is finding a negative angle, which is starting and then going to the counterclockwise, and negative 340 degree is the coterminal angle for 20 degrees. Let's say I go around like this. I start and I go around once and twice to end here. So then I did 360 plus 360 plus 20, which makes it 720 plus 20. So 740 degrees is also my coterminal angle. So if the question asks, write all possible coterminal angles, what you can do is this. The angle value that you're dealing with, so unknown angle, right, theta, plus 360 degrees times n, when n is an integer. This is how you can write every possible coterminal angles. And you don't need to write plus minus 360 because integer is negative 1, negative 2, negative 3, and then all the positive numbers possible. Does that make sense? If your angle measurement was written in radians, you will simply change 360 to 2 pi, and then you'll write the same formula, and I will understand that you are trying to write every possible coterminal angle for a given angle. So then, excuse me, let's look at some of the example questions. So this one, you need to count how many times it goes around. So I know for sure that it is going around 360 degrees. So it's just 360 plus something. Well, it goes another 90 degrees. And then it says this much is 80 degrees. So if you add them up, you are going to get the angle for that terminal side. So that's 440, 530, I think. So the answer for this one is 530 degrees. This one is going clockwise, so I know the angle will be negative. And this much is a 180 degrees, and then this much is 150 degrees. So when you add them up, it will give me negative 330 degrees as an answer. Okay? Alright, so that's coterminal angle, and I told you that we are going to also learn about reference angle, right? A reference angle is very, very important because it allows you to do trigonometry easier way in algebra. So the reference angle, you have a 4-quadrant. So the reference angle for the first quadrant is this much. So a reference angle is always with the x-axis. So x-axis always is your initial side. And then you have to measure how much the terminal side goes from the initial side. So the reference angle is right here for the first quadrant. So this is quadrant 1. For quadrant 2, again, it starts from the x-axis and you measure from the x-axis. So I know that your angle is this much, but when I say reference angle, you need to give me this measurement, not the purple one. And then the third quadrant is again with the x-axis, so it's right here. I think the most common mistake is measuring this much. That's never your reference angle. Your reference angle always comes with your x-axis as an initial side. So this is your reference angle. Then last one, which is the quadrant 4. Reference angle starts with the initial side of x-axis, and it goes and it meets your terminal side. So as you can see, your reference angle is always an acute angle, meaning that it's less than or equal to 90 degrees. Okay, so your reference angle is never greater than 90 degrees. It's always going to be a positive angle, and it always has an initial side as an x-axis. So let's look at number 1, the one we did to answer the actual angle measurement, but we are going to answer What would be the reference angle for this angle? Well, it's in the quadrant 2, so the reference angle is actually this part right here. And I don't really care how big the angle is. I just really want to know what that little angle is. And it says the green part is 80 degrees. And since this quadrant has to equal to 90 degrees, the reference angle for number 1 is 10 degrees. Okay, I hope that makes sense. Let's look at number 2. Number 2 is a first quadrant angle. So my reference angle is this blue part right here. And it says that the green angle is 150. So then the whole thing has to equal to 180. So then the reference angle is just 30 degrees. Okay, let's do number 3. My reference angle is right here. And the green area is 155, but 155 plus this reference angle has to equal to 180. So this reference angle is 25 degrees. And this one, the reference angle is already given, which is 40 degrees. I hope this reference angle makes sense. Okay, let's look at number 6. Number 6 looks a little bit confusing. My angle is in the second quadrant, right? My terminal angle it ends right there. And it's the angle that makes up with the x-axis, not y-axis. So your reference angle is 70 degrees, not 20 degrees. Okay? So that's it for today, really. You need to know how to measure negative angles. A negative angle just means that you are going clockwise from the positive x-axis. You need to know how to find coterminal angles. It's either adding 360 or 2 pi or subtracting 360 or 2 pi to your given angle. And it matters how many times this thing went around. Sorry. Because basically the rotation, this rotation gave you how many times you had to add 360. So this one was 360 plus 360 plus whatever that angle was. Okay, so it is quite important information. It's not that it's just having fun during all this spirals. It does mean something. It means that you went that much more. Lastly, you need to be able to find reference angle when I give you either graph or as just a number. So let's see the question with just numbers. All right, let's start with 245 and then I will just do number 8. Okay, so it helps for me to draw approximately where this angle is so that I know how to get it. So 245 degrees is more than 180, but it's less than 270. So it's somewhere here. So 180 plus some angle will give me 245. So then the reference angle will be whatever I'm adding to 180 degrees to make 245 degrees. So it's 245 minus 180, which is 65 degrees. Do you see how it's a lot easier if you draw the angle? Let's look at number 8. Number 8 is a negative number, so we have to go this way. It's greater than 360, so we go around one circle. So basically, I add 360 to negative 685 degrees. Then I get negative 325 degrees. Negative 325 is more than 180, more than 270, and it's somewhere around here. So it's my first quadrant angle. So basically, how much is it missing from becoming 2 full circles? And 2 full circles will be 360 times 2. So if you do 720 minus 685, you will get your reference angle, which is 35 degrees. So the reference angle for number 8 is 35 degrees. It might be a strange concept, but the math that goes into it is actually quite simple. You need to play with the number 360 and then the multiples of 360, and you'll be able to find it if you know how to find reference angle in a different quadrant. So that's it for today, and I will see you tomorrow.